Que la famille. Que la famille.
Hi everyone. Let's talk about RabbitMQ. Just to be clear, so my name is Quentin Adam. I have this unpronounceable Twitter handle, which is very cool because it's available on every social network, except there is one guy who stole it for me from Pokemon Go. And if you can find this guy, I have to discuss with him. So my day-to-day job is managing a company called CleverCloud. CleverCloud is an IT automation company. So basically what we do is you are a developer, you just writing code, you git push on top of CleverCloud, and we manage everything. So we deploy, auto monitoring, auto sanity and health, auto fixing the operation system, bugs, security, everything. Like basically we run the stuff and you make the code. And it's a pretty good company because we do that on cloud computing based or on-premise directly on customers. We have customers in 1,700 cities in the world, and like big customers and like bank, lots of fun people, or small customers like, for example, startups, a lot of startups in the family. And it's very interesting to see the difference in the way they work and how they manage to have good design, bad design, everything. And we try to learn a lot of all the things and give back to the community and be there for them. So let's talk about RabbitMQ. The basic idea is now we're writing applications. And the application we write needs to be more and more complex because we have applications we basically are there for changing the way people work. We automate the way people work. So the application we write now are more and more complex, and we try to think about splitting application together. I don't know if you're the microservice things, service-oriented application, all this kind of stuff. The basic idea is to say, okay, can we split the application to just focus on specific tasks for specific use? Like taking something simple to do for one application and be specific on that. A common case, for example, will be someone who have a bit monolithic PHP application and try to say, okay, I need some WebSocket inside it. One of the way can be, okay, we will rewrite it everything on node.js, or maybe we can communicate stuff. Try to have the node.js part who will be the WebSockets thing, and the monolithic PHP application will continue to grow and be what it can be done for that. So now, with the whole microservice approach, we need to have this ability for application to communicate with each other. And the first, I think, reflex for a developer will be thinking like, okay, I will use an HTTP API because I really know how to do that. But the problem with HTTP is it's unidirectional. When you're doing HTTP, you ask for something and the server answers to you. And it's not something where you can have a direct pipeline of communication all the time. The other point is you can have a CK inside HTTP. You can run a task and then answer the question. But if you have a very complicated task to do, you cannot acknowledge the task is done with HTTP. We're just like, okay, can you convert this big video file from this video codec to this one? The first option will be like, I convert, then I answer to HTTP, and while it's very long, the client has timeout. And the other option is say, yeah, sure, I will do that. But there is no, acknowledgement that the task is actually done. The other point is about the routing. When you're doing some HTTP stuff, you need to have routing task in front of it, like for your API, then have a reverse load balancer, and all the stuff around that, and the authentication on top of that. Because if you have an internal API, okay, there is people making internal API with authentication, with the, trusty network stuff. I don't. There is no network you can trust, and if you do that, you will have a problem eventually. So there is an article about this kind of trusted network ID in the blog of Clever Cloud called "The End of Fortress Metaphor." Just go there and read it if you have any open things inside your infrastructure. But if you need to authenticate all the calls through your APIs, you need to bring them out, maybe creating some hashmag thing, I don't know. So it's a little bit of work more. So the basic idea when we try to make some application communicate each other will be, okay, what do we need to share from one to another application? And the point is, we all sharing events. And events is something happens in the precise point of the time, and people will listening events and managing that stuff. Exactly like we do with JavaScript, you know, when you had an event listener or something. But imagine you can add an event listener on your whole infrastructure-wide system. It's basically what I think it's important. The ability to diffuse events to service and component when they need it. And the point where is, when I say that, what I want to do is the ability to duplicate events, to have many people's different services will be able to listen that. So what we are trying to achieve is something called the message broker stuff. Message broker is basically this technology. We have used ever GMS from the Java stuff. Yeah, ZeroMQ, Redis as an event diffuser. Yeah, I know. Celery is for the Python guys. Kafka. We think it's a good idea to have some files who had an cron files, who check if it's a good idea or not. It's not a good idea, you know, but lots of people diffuse events like that way. And then who used RabbitMQ before? Okay. RabbitMQ is based on something called the AMQP, the Advanced Message Queuing Protocol, which have been created by JP Morgan. The basic idea of JP Morgan is we have some events happening, and we need to communicate this event between us and others bank. And we need a way to have events about financial stuff spreading in many organizations. So they created AMQP, and they created AMQP with other banks, like the Dutch Bank and the Bank of America, and other users like the Homeland Security, and many implementers like Software Edge, Red Hat, WSO2, Microsoft. And everything is going to be a new specification inside the Oasis specification group. I don't know if you know Oasis before. It's like W3C or EATF, but for other specifications. So it's Oasis. It's another specification group. There is many implementation of AMQP, which is very interesting. There is very paying, very expensive implementation like IBM does one. There is several projects inside Apache, like ActiveMQ and everything. And there is other implementation, like proprietary implementation for doing some banks. There is small controversial between the 0.9.1 and 0.10, which will be the 1.0 implementation, but really it's not really important if you want to use just RabbitMQ. Okay, so why using RabbitMQ? First, it's a well-known implementation. I think it's the most used implementation of AMQP, and it's made with Erlang. Do I have heard of Erlang before? So, Erlang is a very weird language invented by the people of Sony Ericsson, and they invented it for creating call center system. So it's for server on the telephony stuff, and it's a very old language. It's on the 80s, something like that. And the demo on the beginning of Erlang was very fun because you have like, two engineers with, the shirt and the, comment on dit moustache déjà en anglais? Mustache, okay, and everything like that, and they are on stage, and they have a phone call between each others, and there is a third engineer coming on the middle of the stage and just grabbing part of the telephony center, and there is absolutely no difference in the phone conversation between. Basically, Erlang has been built for high availability application all the time. It's very focused on that. So, in the platform we call Erlang OTP system, and Erlang OTP is something very robust if you want to build an application where you can't have any downtime. One of the very interesting features of Erlang OTP platform is you can update an application while it's running. And part of the application will be updated during the runtime of the application, which is really awesome. You pay this kind of feature on the readability of the code, like clearly. But it can be a very interesting feature. So RabbitMQ have an interesting other point is it's been there for a while now, and there is SDK for all the language and platform I have ever find an SDK on. I have find it, and it was really very well done, and it was working, and it's a good point. So you can use RabbitMQ on almost every platform. The point is, when people trying to use RabbitMQ for the first time, they say, okay, it's a message broker. So what they see is there is a pipe. I will put a message on one side of the pipe and get it on the other side. But not. It's not working like that. So people starting RabbitMQ doesn't understand closed RabbitMQ. So I will explain the few concepts where AMQP and RabbitMQ are working on. First, RabbitMQ and the whole AMQP thing have to be able to manage physical and virtual stuff. So if you have a physical cluster of 5 nodes, you can have something we call the virtual host, which is a logical cluster on top of your physical cluster. And you can have many virtual hosts. They have absolutely no possibility of communication between them. We actually run on one physical cluster, which is a very interesting feature if you want to have like sharing and everything on top of that. So it's one of the features. So you have the virtual host, which is the logical cluster. Then you have the publisher. What we call the publisher in the AMQP world is the program will actually send message. You have the consumer on the other side, which is a program will actually grab some message. And with them, there is plenty of stuff. First, you need to understand that there is a connection to the cluster. What we call a connection inside the AMQP world is really the TCP and authentication connection. That's all. And the connection itself has something we call channels, which is actually the logical connection. So the connection is really low level, how to manage the exchange of data between the client and the cluster. But the channels is more the logical connection stuff. Example, I am writing a web client for IRC, for a chat, and in IRC gateway. Every client who just connect to the interface, I will create a channel for him to have the logical connection of the client and the WebSocket inside it. And if the client dies, I will destroy the channel, which is the logical connection. And as we will see, it can be game changer on some feature of AMQP. So really, you can create the number of channel you want because there is no overhead of a channel. It's really just a logical point of view of what is the connection. Then there is the exchange. The exchange is the inbox. When you send a message, it goes to the exchange. And there is a queue. A queue is a way out. And you have to explicitly bind a queue to an exchange. By default, if you create a queue, there is nothing inside it. If you put a message, it will not go inside a queue. But you have to bind and say, this exchange puts the message inside the queue. And this is the most complicated thing to understand. But after that, it's very impressive because you can draw a large number of topology on top of that. So first, answer the other point is the message. About the message, it's something important is you have headers and a body, exactly like HTTP. So you can have a context and the body, which is really like what you need to share. There is absolutely no mandatory stuff inside the body. It can be JSON, it can be binaries, it can be anything. AMQP think it's a binary. So the AMQP cluster is never able to see what it is in body. It just root it, okay? And by default, it's a binary. So if you store something inside it, you need to have the convention inside your team of what it's inside the body. Exactly. So there is one important header called the routing key we will speak about, which is really important to spread message inside the cluster. So to summarize, you have a publisher, the publisher publish inside an exchange, the exchange route with a binding to the queue, and the queue is consuming by a consumer, okay? Consumed by a consumer, okay? Cool. And now the different exchange and how it works. First, you can have something we call the AMQP direct. The exchange is there, and each time you bind a queue inside it, you can say there is a routing key. And each message will have a matching on the routing key and just get the message of the routing key you just bind. So you can have many queue bind on this on this exchange to get different kind of routing key. You can have a queue bind with the whole routing key pattern. It's okay. But you can split that way. What is important is, on this case, there will be load balancing between the queue of the message get on the system. Another point is the exchange called fanout. Fanout is a very simple message. It's a very simple concept. You have the exchange, every queue bind to the fanout, get all the message. Simple. And a duplicate version of all the message. Then there is a topic. Topic is basically direct plus fanout. In fact, you will have a copy of every message matching a routing key, which is really, really cool. In my work, I think there is 80% of the time I use a topic, okay? So when you bind a queue, you specifically say, okay, there is a routing key I will use, and you can have different type of message inside the same exchange. Okay? Everybody gets it? Okay, cool. There is another kind of queue called AMQP match, which is basically made some regex rules on top of message headers. And you do that when you have failed on something inside your topology. It's you using that, it seems if you have failed something, and it's way more aggressively used the CPU, so the performance will be less interesting. But it can save your ass on sometimes. You can listen on one queue with many consumers, and there will be load balancing between the consumer. Okay? Which is one an interesting thing. You can also bind an exchange to another exchange if you want to spread messaging on more complex stuff. And now what's interesting is you can describe topology you cannot before. What is interesting is inside RabbitMQ, you can describe the topology of routing message, which is pretty cool. The other point is there is the acknowledgement. Each message, so when I see each message, it's message inside the queue, not inside the exchange. When a message is routing to the queue, even if it's duplicated, if message have to be acknowledged. So you see I have get this message and I have done my work with it, which is really important. So when you get a message as a consumer, you get a message and it go to the non-acknowledged zone, and you have to manage this and get back the message saying, okay, it's acknowledged, the message I've been treated. What you need to understand with this is, when you do that, there is a number of, it's configurable when you do the connection, of message with no ASCII key you can have in the same time. If you never ASCII key message, it just, lost inside the I'm not ASCII key, I'm waiting. If you want the message goes back to the queue, you have to cut the channel. Because it's inside the channel who requires the message. It cuts this, and the message will be requeued. Okay? So that's why using multiple channels is important. Because sometimes your code logic, it will be more interesting to have cutting of the channel and the message will go back than cut the actual real connection to the cluster. Okay? And yeah, it's basically what I just explained with, in fact, when you push a message, you can say it's requeue, or it will go to the dead letter exchange if there is no ASCII key. So the dead letter exchange is a default exchange for the message lost in translation. Okay? To be clear, there is absolutely no way to implement timeout on the message. So basically, if I get a message, no ASCII key on that for 2 days, the message will be lost on the non-ASCII key world for 2 days. The only way to just break the point is cutting the channel. What is really important too is, if I create a consumer saying I have 10 buffer message with no ASCII key, and I get 10 message with no ASCII key, the server will not give me all this message. It will wait the new ASCII key message. Okay? Yeah, it's exactly that. It's a buffer by consumer. There is also interesting part, which is the queue parameter system. In fact, a queue can be durable or not, and exclusive or not. So, if your queue is durable, if there is no consumer, the queue continue to exist. And if nobody consumes, there is just message piling in. Okay? And when you connect a consumer, it will get all the message. If the queue is not durable with an auto-delete parameter, what's happening if there is no consumer on the queue is just dismissed. What can be really interesting, because if you have an exchange with a lot of message inside it, bind a queue to it, the message will be accumulated inside the queue if you don't consume it. You can break the whole cluster that way, which can be very complicated. The exclusive things is another part, which is you can say at a point there is only one consumer able to consume message on the queue, not two, which will allow you to have a linearity, not really, because there is no guarantee of the linearability inside RabbitMQ, but a linearability of the event inside this queue for a consumer. So this is this kind of queue parameters and the queue lifecycle of creating a queue, deleting a queue. So basically, as a developer, you're creating and deleting queue all the time, which is a good thing, because it's really, really not costly. But it can load all your message in the memory, and you can break your cluster just because you have a lot of message inside the memory. There is a parameter to store message not in the memory but on the hard drive, but it's way more slower. But you can do it by queue. It's a choice by queue if you want. Okay? I'm trying to finish all the concepts as quickly as possible, but there is a lot. If you want, you can have something we call request reply pattern. It's very difficult to say. request reply. So basically, what's it said? I'm creating a message saying I need an answer to that, and I will post the answer inside this queue. And the first is it's a specific header, and it's included in all the RabbitMQ system, which you have just you post the message, the consumer will get the message. No, you have to answer to this message, and the answer directly in a specific exchange with a specific routing key will route the message to a queue which had random generated name, exclusive and not durable. So when you require replies, or when you have this pattern, you require something, you send a message, creating an exclusive non-durable queue randomly generated, and when the answer goes back, it lands in the queue. When you depice the answer, you can just stop listening this queue, and it will be automatically deleted. So it's inside. It's a system inside all the RabbitMQ system and all the clients, and it's very interesting when you need to ask for something and be sure you will get an answer. So make some topology crash test. I can start if you want. Typical use case I used on my startup. We have the logs of every application deployed on Clever Cloud. So basically what I said is more like it have to be through like few months ago, because we have too much log for RabbitMQ now, but anyway. We have all the logs of the application. We push it all inside one exchange on RabbitMQ called logs, with, as a routing key, the application ID. When someone wants to have real-time log, it just connects inside a WebSocket to an API. The API created a channel linked to the WebSocket, creating a queue bind to the logs, routing by the application ID, and get all the logs. If the WebSocket dies, the channel dies, so the queue dies, everything is okay, will not store any message. And it's okay. It's very simple. And the queue have a random generated name to be sure that you can connect with many clients you want. Okay? Simple. And very convenient. What is interesting on that is the cluster. The cluster is very stable, you know, and you have several stuff you can do on that. Like, for example, I have availability. By default, when you connect a queue, is linked to the cluster node you have. You can say this queue is important, and if I lost this node, I don't want to lose the data of the queue, and the queue will be replicated across the cluster. It will cost you some performances. It's same thing already, you know, but it can cost some performances, but it protects your data. The other point is called federation. Federation is amazing. You have a cluster in RabbitMQ there. There you have another cluster of RabbitMQ. And you can say, on these two exchange, please act like one. Which is amazing. Because you can have a high message rate on the two clusters and just a few messages you want in the common. And there you can do that without implying the performances of the old cluster. This is the federation stuff. And like this, you have many plugins, and there is a very convenient plugin system inside RabbitMQ who can help you to bring a lot of cool stuff there. For example, there is gateway for Stomp, MQTT, WebSockets, a lot of stuff like that. Very convenient as a users and very simple to use. We have RabbitMQ in production for more than 5 years now. In more than 5 years on all the cluster, I think we have only 2 incidents. The first, we were young, our monitoring was not ready. We have a full disk. Basically the logs, full disk, and it crashed the cluster. And the second one was a very complicated trouble on the network. We basically split brain of the stuff, but very difficult to break. With Kafka, like 2 or 3 times per month, we have to work on it. RabbitMQ, Never heard about that. And you have a very stable things where you work and just like it's running, you know. You don't have to think about that. Why it's so cool for a startup point of view? As a startup, you never know if what will be the future of your product. So what you have to do is to invent new things, new feature every time. And the point with that is if all the data of the company are going to exchange inside the RabbitMQ, I can basically just branch a new queue everywhere getting the data and creating an absolutely new service, absolutely new feature without have any impact on anything because I just copy the data to the new service and it's very cool. I can even do this in my laptop, just plug in the production from my laptop and it works. And we use it for a lot of cool features. Like, for example, when you had the logged range inside Clever Cloud, logged range is the ability to just say, okay, send me all the logs in this UDP or HTTP gateway for all the logs. Basically what we do, and we have discussed before, and we just have to create durable exclusive queue named by the drain ID. Inside the cluster, it will get a copy of all the logs. We will be sure there is only one people consuming it, and it will send the data to the log drains. And that way, there is absolutely no impact on the rest of the infrastructure. It's just like we add some queue. Okay, there is more load, just add a node to the cluster. But it's really simple, you know. And that's why, as a startup world, I really enjoy this stuff. Because many times on the history of Clever Cloud, we just say, okay, all the data flux is there. We just have to put another queue and get all the message at all, which is amazing. I will show you some code of running it, not with PHP, not with Java, but with node.js, because we are in the family. Okay. Cool. This is a code of example. To zoom inside, we start require AMQP. Then we have the configuration of the cluster. So we have connection with the host, port, login, password. Okay, anything? Yeah, sure. I absolutely forget to say, but there is authentication on top of RabbitMQ and ACL system. The timeouts, the authorization mechanism, the virtual host I connecting to, so in this case /, and you can say I will use SSL or not. I have to say there is a poor choice on the node.js client. By default, it's auto-generating some channels. So you will not have a clear point of view on channels with the node.js client because the basic idea of node.js client is we are mono-thread, so it's not a problem. But I think it's sad. But anyway, so with this, when the connection is ready, we are creating a queue, and we are putting some listener to the queue is bind, and the consumer is bind, okay? And then we have a function to bind the queue to my topic. And it's simple like that. And when it binds to the my topic, it's okay, we can execute the queue bind awk. And there is a subscribe one, which is basically just get me all the message. So this code is very simple, you know, like just listening message and that's all. And I just have to publish message. So really, it's simple. From a Java point of view, just to give you the insight, when I have a connection, I create a channel, and I hacked on the channel for declaring exchange, declaring queue, and all the stuff. And it's really simple. You know, it's what I really like is the API of every client is almost the same across languages. So when I go inside a new platform, it's really simple for me to just jump in and starting to try to add some new things. You can have API for higher level. For example, this is a Akka stream in Scala example where you're just creating a source from the publisher, which is a queue, and where you have a buffer, and you have the out is not something you have to think about. And after that, you just have to say, okay, I'm taking my source, I'm putting inside the JSON if flow, and getting some. And this is actually a very simple message to manage a stream. So you have this kind of integration if you have like very high point of view API if you want to use it. Basically, all the thing I explained before about the log system inside Clever Cloud is built using Akka stream on top of RabbitMQ. So no Scala, no Kafka. So. And that's all. So 2 announcements, cool. First, Clever Cloud will release in, I don't know, few weeks, a plugin very cool which is able to give you the ability to not have an account on a RabbitMQ system, but use a macaroon to connect to the system, and after a very more precise way to have the access control, because you can this way say, okay, I can push a message with only this kind of routing key, this kind of stuff, very interesting. And we will release it open source. If you need this kind of stuff, just send me an email, and I can include you in the release process. And Clever Cloud is releasing a new AMQP add-on on top of the platform. So if you want to try it on the beta, just say hi to the support, I need a RabbitMQ, and we'll get back to you. So thank you very much for listening, and I'm available for questions. Sure, there is a Clever Cloud the Family Fellowship option, and I have wonderful stickers I can give it to you too. Thank you.
You gave an example with a node.js server, which connect with the browser with WebSocket and use the queue. Have you ever tried to use a Stomp or a direct WebSocket between a browser and RabbitMQ?
I tried once, but it was more to play, because the point is, it's very non-convenient to have not authenticated WebSocket stuff. So at the point we have some logic and authorization and authentication inside your application, and that's why the RabbitMQ is proxied by a WebSocket system, which will be on Node or Scala or anything, but it's more like for business logic. Sure, you can write all the business logic and authentication system inside a plugin for RabbitMQ in Erlang, but do you really want to do that? I don't know. But if you want, it's cool. But it's more like that, yeah. You can also have plugin for login on site RabbitMQ with LDAP or something like that, if you want. But you know, it's this kind of case. I just feel like you're just running a middleware which has a very simple way with more and more code from you and plugins and things like that. So it will become more and more complicated to operate, and I'm not so sure with that. I prefer a separate application for that.
Hi, there is something in the RabbitMQ environment, or maybe AMQP in the node called RPC, or remote procedure calls. Do you have any more insight aside from that? How is this different from what your usage of AMQP or RabbitMQ?
There is people using RabbitMQ to do RPC, yeah, sure, because of the require replace pattern. So you can do this kind of stuff, yeah, sure. But you have to do it yourself. I don't know if there is a kind of Salt or anything on top of that using it. I know Salt is using ZeroMQ, Puppet is using XMPP, I think Chef is using RabbitMQ. I don't know, but I think Chef is using a RabbitMQ.
Last question? Okay.
Cool, thank you very much. I will bring more Clever Classic.
Thank you.
Que la famille.